Hello, I just want to take a couple of minutes really quick and go over with you the directions on how you're going to complete this assignment. First of all, before you do this, you need to make sure that you have gone through the atomic structure review slides and filled out the table, the notes table that goes along with it, just so you're familiar with the terms and where we're going to get all of our information from. So if you haven't done that yet, go back and do that before you attempt to complete this assignment, okay? Also, in order to do this assignment, you're going to need a periodic table. And I provided you with a yellow cardstock periodic table in the packet of stuff that you picked up when you came for that in-person registration. But if you don't have that for whatever reason, it's no big deal. You can just do a Google search for one. There's bazillions of them on the internet. I picked this one because I like the green color. So you can use really any periodic table to do this, okay? So we're going to start off really quick. I think a lot of these things are pretty straightforward. Again, I know that you've seen a periodic table before. I know that you're familiar with subatomic particles. This isn't the first time that you've ever heard about them. So what we're doing now in high school level chemistry is just doing some different kinds of calculations and helping you understand exactly what the numbers mean and what happens, especially like when the numbers change. So to fill this out, I think that it goes, like I said, pretty easy here. The element symbol, we know that we're dealing with helium, right? So if you don't know off the top of your head what the symbol for helium is, you can look it up, but you can see it right here on my periodic table is He. Okay. Then we want to know the atomic number. So the atomic number is the whole number that's on the periodic table. So I'm just going to write down whole number. In other words, it's the number that doesn't have a decimal. I believe on your yellow periodic table, the atomic number is on top of the symbol, but I don't want to be quoted on that. I think it looks very similar to this table that I found online. So we can see that this whole number on top here is 2. Okay, the next thing that it has is the mass number. Okay, and there's a couple of things we need to understand about mass number. First of all, it's not on the periodic table, and I'm going to do PT, right, to represent that. So it's not on the periodic table, right? The way we find it is we take the protons plus the neutrons to get the mass number, or it's in the name. So notice here that the name of this atom that we're talking about is helium-4. And see how we have the word isotope there? That's just to clarify that we're talking about a very specific version of helium. So this data table, or this table that you're going to fill out, is really talking about individual atoms. If we were talking about helium as a whole, then we would actually have many different versions of helium based on the isotopes, based on the number of neutrons. And that's when we would use this number here with an atomic mass. And when we start talking about the mole in October, I'll explain atomic mass a little bit differently to you, but atomic mass is not anywhere on this chart because it refers to big groups, big samples of atoms, okay? So for helium-4, the mass number we get by looking at the name. So we're going to take that 4, and that's our mass number, okay? Now, the next thing we need to do is identify the number of protons. Remember that protons are the same as the atomic number. So there are 2. I'm going to say here, just for notes, that these are the same as atomic number. Sorry. And then it also wants us to identify the electrons. We are talking about neutral atoms in this activity. And so a neutral atom means that the positives are going to equal the negatives. So since they're neutral, we know that the protons are going to equal the electrons. So if there are 2 protons, then there are 2 electrons. And then the last thing we need to do is figure out the neutrons. Again, neutrons is not on the periodic table. We have to solve for it. We know that mass number is equal to the protons plus the neutrons. So if we just want to find neutrons, it's going to be equal to the mass number minus the protons. So in this case, the mass number is 4, and there are 2 protons. So the number of neutrons is equal to 2. Okay, so that's how you go about filling out the data table or the practice table here. I'm going to walk through one more with you just to kind of give you an idea of how you work around with all these numbers. So let's check out this element right here. It's MO, and it gives us a mass number of 97. This doesn't really help us for finding it on the periodic table because, again, remember, this number isn't on the periodic table. So we have to look on our periodic table and track down the element MO. And I'm going to cheat because I know off the top of my head that that is element number 42, molybdenum. Okay, and so we're going to put down the name molybdenum, which there's really not enough space for that here. Oh, sorry, I got to switch to the camera. And remember that the name has to have 2 parts. It also needs to include the mass number. And in this case, we already know what the mass number is. It's 97. So this is going to be molybdenum 97. And I think I'm actually going to try to rewrite this a little differently so we can get that in there. So this is molybdenum. Sorry about that tiny box. I usually do a better job with that. Molybdenum 97. So the name of the isotope always has to include the identity and the mass number. So I'm just going to write that up here. So it's got the identity and mass number. So molybdenum 97. Next thing we want to know is the atomic number for molybdenum. So again, let's just check it out on the periodic table. It's that whole number that's up there on the top. So in this case, it's number 42. And remember that the atomic number is equal to the number of protons. Okay. And then remember that the protons is equal to the number of electrons because this is a neutral atom. So this is 42. And then finally, in order to determine the number of neutrons, we just need to know the mass number and the number of protons. So we've got 97 minus 42, and that would give us 55. So the number of neutrons is 55. So I think it's pretty self-explanatory. You can see there's a couple of places where you'll work backwards a little bit more from having the names, but once you know that this is where all those pieces of information come from, you should be able to fill those out. So as always, if you have any questions, please reach out and let me know, and we can set up a time to meet during Access if we need to, or maybe we can just text or remind if it's an easy question. So have a fun.